Okay, so let's start going over that pipeline from code to a running workload, and let's see all the different steps we just described in the last slide. So if I will start from the code itself, you can build your code in a secured way from building blocks which are supported, curated, secured by VMware and the community. Spring Initializer is one of those frameworks that will allow you to do that. For Java code, you can use Tilto initializer to do the same for .NET Core. In this case, if I'm just gonna create like a demo application with a web server, I can decide that I'm choosing Spring Web. And I can also add different dependencies from security, let's say Spring Security for different other options and authentication and Okta integration and others. And that specific initializer will eventually create a package of code which I then can push into my Git. So in this case, I've created my Spring app that basically does only web server with just one index HTML, and I've pushed that into my GitHub. And that application eventually is just one slide or one web page that has the logo of Carbon Black and Tanzu and says Hello World Build Service and Carbon Black Demo. Now that code is still raw, and I need to build that code with the help of build service to create that a container image. And in that build process, Tanzu build service will help me choose the right dependencies, the right application framework, and the right environment variables for my code in the most secured and best way. So now let's create a container image from my code. To do that, I'm gonna apply a kp image command for Tanzu build service, basically stating what's the tag for the container image and what's the source, the Git that I just showed you. Once I'm building that image, Tanzu build service will automatically start a building phase. You can see that here. What you see, by the way, is Octant. Octant is an open source dashboard for Kubernetes with a Tanzu build service plugin. So if I will click on CB demo, I can actually see the build that is being processed right now. The ID is 1 and it's building because of a config. If I will click on that, I will see different steps in the building phase. And if I will go to the build, you will actually see that build service is building right now my Java application, again, with dependencies and application runtimes, which is opinionated by VMware. And it's the most secure way you can actually build that. If something will change with those dependencies and you will need to patch them, or there's a new vulnerability that should be handled in updating one of the layers, Tanzu build service will do that for you automatically, just like we've just created the image. If something is changed in the dependencies or in the code, Tanzu build service will automatically create a new container image. Now, eventually, when it will be completed, and it's now completed, I can go to my Harbor, which is our image registry. Inside the projects, inside Tanzu and CB demo, I will see a new container image. Now it's already being scanned. That scanner, I can see that scanner in interrogation services. Under the default one, I will see the CB scanner. That's the Carbon Black container image scanner. And that's the container image scanner that actually scans that container image automatically. The reason it's doing that is because in the configuration of the registry, I've decided to automatically scan images on push. So that's why it's automatically scanning that image. Now, if I didn't want to create that automatic flow, or if I wanted to check that image even before getting into that registry, I could have used cbctl, which is our command line with the flag of image scan. That will allow me to basically take any image, not just the one that I've built, and scan that with the mechanism of Carbon Black container security and Carbon Black image scanner. So if I will choose just Nginx, just for fun, I'm now pulling Nginx from the web directly, so from Docker.io, and I'm scanning that image. Now you can already see that the one that was built is already scanned, and I have some vulnerabilities. I have some high, medium, and low vulnerabilities. Inside the Harbor UI, I can see that, and if I will click on that, I will see each and every one of the artifacts with the vulnerabilities for that specific revision. But I want to see that in a more holistic way and understand in a better way what's my security state and what's my risk. And for that, we are exposing and basically reflecting everything inside Carbon Black Container Security. So if you will go to your Carbon Black Cloud dashboard and inside inventory image repositories, you will see the ones that I've just scanned. So you can see Tanzu CV demo. This is the one that was automatically been scanned with Tanzu build service or from the pipeline of the Tanzu build service. And you can also see the one that I've created manually with Nginx directly from Docker.io. So if I will click on the CB demo, you will see there's different revisions. The latest one is the one that we've just pushed. And if I will click on the latest one, you can see I have exactly the same output that you saw in Harbor, but I have that in a more elaborated way, and I can understand now the difference between the latest one and other ones, other revisions in a single pane of glass. What's the packages which is part of that image? What are the vulnerabilities in that image? So I have 4 highs and mediums and so on and so forth. And if there's any Kubernetes workload that's actually running that image right now. Now, of course, if I wanted to not connect my Harbor, or if I'm using other registries, which we will have capability to plug in as well moving forward. But for now, if I want to create an interruption in that CI and create something which is another step in my CI for that image scanner, I can use CBCTL for that, and that will help me get an output in the middle of that process and decide if I want to stop the pipeline or moving forward. Okay, so now that I have my image already scanned, now I need to basically decide about or check my configuration or misconfiguration for that image being deployed into Kubernetes. So now we are transitioning from the CI, from the integration and build, more into the CD. And in the CD, we have 2 different phases. One is the preparation, where we are creating some kind of manifest to pull that image and then deploy that into Kubernetes. And in that preparation phase, we can stop the pipeline as well, even before trying to deploy anything to Kubernetes, without doing anything in an actual kubectl apply or deploy or create or something like that on Kubernetes, and just stop and check if it's aligned with our policy or not. Now, in this phase, we also dividing the different phases to different scopes. And scopes is a notion which is really important in Carbon Black Container Security, because it's allowing you to divide the way that you're addressing your build phase and the way that you're addressing your production phase. So the build phase can have a build scope, and in that build scope, I can check different things and maybe not be as strict as I need to in my deployment phase, in my run state. In that kind of scope, I will have all the different interactions with CBCTL, let's say. And CBCTL is not just image scanner. So if I will take the same CBCTL and I will change the flag to Kubernetes object validate, I will be able to validate my YAML file against policies. So let's do that now. So in this case, I've created a scope of the build. And if I will go to enforce Kubernetes policies, I can see that I have a policy for the build phase. If I will click on that, next, those are the different aspects I'm checking in my build phase. So when I will run CBCTL command with Kubernetes object validation, I will get alerts if the container image has the need for root access, or if it has privilege escalation, or if it doesn't have memory limits or CPU limits, and so on and so forth. So in this case right now, what I'm gonna check is a simple YAML file, and the simple YAML file that I will check is Kubernetes demo deploy, and that's just a deployment that will pull that Harbor image from my Harbor, exposing that with port 8080, and then externally exposing that with a load balancer service in port 80. So what I will run is CBCTL Kubernetes object validate, and I will point out that YAML file. So what CBCTL did right now is to check that against the policy of the build that you see on the left side, and those are the violations. So required hashtags, enforce non-root, memory limits, and so on and so forth. And that will allow me to decide inside my pipeline, even before trying to deploy something, what is the risk, and if there is any misconfiguration from my baseline, or from my regulations, or from my methodology of deployment, and stop the deployment even before trying to deploy something on the cluster itself. Now, if I've went over that and now I want to deploy something and I want to block something in deployment, or I want to be more strict, I can create other different scopes. Let's say the run, and the run can be deployed on any cluster on the run state, but I have another option of scopes. So we've talked about the build phase, we've talked about the deployed phase, and I also have an application phase, or an application scope. The application scope is a unique one that allows me to basically address the build and the run, but it will be applied against a namespace, and that namespace can be the same namespace on any cluster that I'm managing. So if I have 30 clusters, 40 clusters, as long as I have a specific namespace for my application, it doesn't really matter where it's running, that policy will be applied on the namespace, no matter where and no matter which kind of cluster I'm managing. So what I'm going to do now is I'm going to use that application scope, and I've created an application scope for demo, which basically applied to the namespace demo. So if I will get the namespaces in my cluster, you will see that I have a namespace demo. And when I will go over my application now, I'm basically applying my policy to that namespace. So if I will go to Kubernetes policies, I will go to demo. That's the policy that I'm applying. And in this case, I've just applied the restricted policy, and I've also decided to block root access. I've decided to block memory limits and CPU limits. So if you don't have memory limits or CPU limits, it will block you. I've used the template of restricted, but I could have used the CIS benchmark or any other. Now, in this case, it's already applied on my demo namespace. So if I will try to do something that I can't, let's say something that need root access, or something that need or doesn't have memory limit. So if I will just run an image, let's run Nginx. And I'm doing that on the namespace demo, right? Because that's the one that has the policy. So I can see I'm being blocked. Now, I don't know why I'm being blocked. I know there's an admission controller. I know it's denied the request, but I'm not sure why it's being blocked. So if I want to know why it's being blocked, I can go back to harden, because that's part of the hardening, and go to violations. Now, of course, I need to remove my get out of that policy editing mode. But now when I'm getting into Kubernetes violations, I can see I have a violation on the scope demo. There's a pod. Nginx was the violator, and there's 4 violations for the policy. If I will click on that, I will see why. First of all, it needs root. Second, there's no memory limits or CPU limit, and there's high severity vulnerabilities for that image. And you saw that when I've scanned the Nginx. So that's why I just stopped that. Now, it's not just for one specific image. If I will try to deploy the same YAML file, again, there's a lot of different things which is wrong here. First of all, latest is not recommended, and it's blocked by me. There's no memory limits or CPU limits, and that specific image needs root access. So if I will try to run that, in a namespace demo, again, I will be blocked. Okay, so and if I want to know again what's the block, I can go back to violations, and once I will refresh, I will see what was blocked in that Kubernetes object. And this is the deployment that I've tried to just run, and that's the blocks. So enforced non-root, memory limits, and again, exactly the same thing. Now, in the hardening phase, even before the block, I have also an option to see all the different aspects of the violations that I have in my deployment phase. So that's a dashboard that will allow me to get in a single glance what are the violations in different aspects of the different things. But the main point, or the main thing, the main value that we need is to understand the risk from those different violations. So if I will go to risk, I can also see the risk analysis, and then in each and every one of them, I will understand why it's so risky, why Harbor Nginx has a 9 risk score and why it's so important to take care of that specific workload. So that's the value that we need to understand to basically mitigate that vulnerability or risk and basically get back um, into health state. Another important thing, and that's the last thing for the demo of this section, and we will go to the network map demo or the runtime portion. We've also exposed Kubernetes Search, which is basically custom queries. You can decide on which scope you want to run that query. Let's say I'm running that on everything, and then I can decide what I'm looking for. So if I want to know if, let's say, there was an execution to container, which is really bad, I can search and I can see there's nothing, which is good. But then if I want to check for enforcement on root, I can see all the different deployments and workloads that use that root access and basically violating that enforcement on root. So I can analyze the data and then create save search to basically save that report. So now I think we can go to the section of the networking and runtime security and basically see the capabilities that we will expose as part of the networking map. I'm going to go over an Acme Fitness application, which is a demo application that I'm using a lot. It's a polyglot application with different microservices in a cloud native architecture. You can see the architecture of the application. It has one main front end, which is a shopping workload. It's connected to the different microservices in the backend, like carts, orders, catalog, user services. And those backend services are connected into different databases and cache layers for that application. On the right side, you can see the application, and that's the shopping. That's a front end basically, and it's also publicly exposed, so you can go and browse that application to see the different components. If I will click on catalog, that means that I'm basically going to the catalog microservice. You can see different catalog items and contacts and so on and so forth. And if you want to see how it's installed on my cluster, you can take a look on the left side of the screen. I'm connected to my Acme Fit cluster. I'm connected to my Acme frontend namespace, and you can see I have one shopping workload in that namespace. If I will change the namespace to backend, I will see all the backend services, so cards, catalog, payments, and users. And in this case, the databases is not installed in my cluster. It's installed outside of my cluster on different VMs. Now, let's take a look on that application from my Carbon Black Container Security Visibility Map perspective. If I will click on the Carbon Black Container Security on Inventory Network, I will see one cluster that I manage. That's the Acme Fit cluster. I have one Egress controller for egresses. The CNI is Andrea. It's built on Tanzu Kubernetes Grid. And I have a load balancer that basically is underneath that Egress controller. If I will click on View Map, now I can see the connectivity of the different microservices and the different namespaces, which is part of that cluster. You can see that I have different system namespaces, like it's managed by Tanzu Mission Control, the data plane of Carbon Black. You can see Cube Public and Cube Systems, but you can also see my Acme frontend and backend, so basically the application itself. If I don't want to see the namespaces for the system and I just want to see my application, I can open up map settings and just remove view system namespaces. That will leave only namespaces which is not part of the system, and in this case it will leave my Acme front-end application, my Acme application. If I will click on load balancers, I will see that I have one Acme load balancer. In this case, it's installed on TKG on Tanzu Kubernetes Grid on AWS. So you can see I have an ELB here, which is exposed. And if I will browse that, you will see the same application as you see on the right side. It's the same Acme Fitness app. So that's the load balancer. And if I will go now to Acme frontend, I will see that basically that external connectivity is getting into the shopping workload. That shopping workload is being browsed by also a load generator because I'm loading traffic just to have some kind of traffic for the application. And if I will click on that shopping workload, I will see how the workload is connected inside that cluster between different namespaces. So you can see that the shopping is basically connected to the Acme backend namespace, to the carts, orders, users, and catalog. If I will take a look on the side panel on the right side, you will see on which port and what's the protocol for each and every one of them. Now, I also have a risk assessment for that workload. And if I will go and scroll to the right, I have view more to basically open up my workload page that will show me more details about the workload. So if I will click on view more, now I'm basically getting in and seeing a lot of different dimensions of data for that shopping deployment. So it's a shopping deployment, it's part of the Acme Fit cluster, that's the image that it's using, and that's part of the image scanner. You can see the vulnerability and fixes for that vulnerability for that image scanner for the specific image. That's the shopping pod which is running. And if I will go to network connection, I will see now here exactly what I saw in the map. So I can go to, let's say, Ingress, and I will see the Acme load balancer. And if I will go to outbound cross or inbound cross namespace, I will see the connectivity to the different cards. So you basically have a workload page that consolidates everything, including hardening perspective. So if it's violating any hardening rules, like enforcement of non-root, memory limits, and so on and so forth. If I will go back to the network map, and we were on the front end side, so you can see the shopping is connected into the backend namespace with different backend services. If I will click on the backend, now you can see Egress Connections. Now the Egress Connections are basically external consumption of services outside of the cluster. And if I want to see exactly what kind of services the specific workload is consuming, I can click, let's say, on users, and I can see that it's going out to my egress group, which is db.acme.local. And if I will click on that, I will see that the databases are outside of the cluster, and that's the way that the workload is approaching them or consuming them. Another thing that I haven't said is you can also create your own egress group. So when I'm adding egress group, I can give it a name, and basically according to a DNS name or a DNS subdomain or an IP range, I can just regroup egress IPs or sources that I'm consuming. So if I will go back to the cluster level, you can see I have TMC control plane or CBC control plane. Those are groups that I've created for the endpoints of that service. If I'm getting the system namespaces back, there's another option of filtering that view, so you can see only encrypted connections, or if you want to see only unencrypted connections, and egress connections to public destinations or to private destinations. So if you're consuming something from within the organization, you will see that as private destination. And that was a short intro and basically a short demo for the network visibility map and the capability to basically understand with one single point of view how the application is being connected, the different components from Ingress external source to internal cluster between or cross namespaces inside the cluster, and from the backend to the egress connectivity outside of the cluster. Thank you for being with us.